This is the 707, Boeing's prototype jet airliner, capable of speeds and altitudes which will revolutionize commercial air travel. The production airliners will fly at high speeds and high altitudes for economical operation. The high altitudes require more fuselage pressure than present airplanes to maintain the passenger comfort level. It is known that certain combinations of pressure, stress level, and detail design could produce a catastrophic explosion of the fuselage. A catastrophic explosion such as this one during tests. In a program directed toward eliminating such a possibility and toward producing a tear-resistant fuselage structure for the 707, the Boeing structure staff has conducted a series of tests on various fuselage construction configurations. For these tests, a full-scale 707 fuselage panel 100 inches long was installed on a steel jig to form a pressure chamber. Additional tests were conducted on a fourth panel with design improvements based on what had been learned in the previous tests. 3 fuselage section designs were used on this panel: the strap design, sheer tie with reinforced frames, and basic design with thick skin. In constructing the panel, the basic stiffener frame panel with thick skin in a spot welded design was installed on top of the jig. The sheer tie configuration with revised reinforcement similar to that proposed for the production 707 airplane and the spot welded circumferential strap design were installed at the sides of the jig. In the circumferential strap design, cracks were propagated from saw cuts reaching a maximum length of 40 inches, but did not propagate through the straps or the contiguous skin. Similar tests were made in the other parts of the panel, which represented the sheer tie with reinforced frames design and the basic design with thick skin. This scene in high-speed photography of a double blade test in the thick skin design area demonstrates the effectiveness of the panel. Despite the numerous cuts and drops made on this panel, complete structural integrity was maintained. To further prove the design's safety and freedom from fatigue of the design, the cuts were patched and sealed, and 25,000 air pressure cycles were applied.